Good morning, students. Today we'll be learning about the environmental engineering and the civil engineering. So, environmental engineering, the first topic that we'll be learning is the population forecasting. So, what is the objective of the environmental engineering? Objective of the environmental engineering is that we need to supply pure drinking water to the every household in the city. So, for that we need to do the population forecasting. So, like I'll be telling you a simple example. So the present population of the city, of any city, let's assume the present population is 1 lakh. So I'm designing the water distribution system of that city for the 1 lakh population. So after next year, in the meantime, the population is increased by 50,000. Let's say right now the population is 1,50,000. So previously I have designed my distribution system for 1 lakh population, but right now the population is 1,50,000. So will my objective for the environmental engineering is valid? No, because I have designed for only 1 lakh people so that I can supply water to only 1 lakh. So that should not be done. For that we'll be doing this population forecasting so that the future population is estimated from the present population. So according to that estimation of the future population, so the same amount of water will be supplied so that throughout the design period of the water distribution system, we can supply water for the whole of the city. So for that we'll be doing this population forecasting. There are majorly 4 methods in the population forecasting that we'll be studying. So first one is arithmetic increase method. Second one is geometric increase method. Third one is incremental increase method. Fourth one is decreasing growth rate method. So these are the major 4 topics that we'll be learning in this population forecasting, so that for the different types of cities, which method will be applying so that the future population can be estimated. So firstly we'll be seeing what is the arithmetic increase method. We'll be seeing line by line the first method and we'll be finishing it very fast. This is very simple topic. So what is arithmetic increase method? Arithmetic increase method is nothing but the constant rate of the population growth. Here we are assuming more or less the constant rate of the population growth. This type of population forecasting mainly will be using this population for old and settled cities. For example, in our country, old and settled cities like Jaipur, if we take Jaipur, or if you take Chennai, it's like they are very old and they are very settled. So the expansion of the city, the scope of expansion of city is very less in these type of cities. So there is not much growth in the population. So for that type of cities we'll be applying this method. So this is arithmetic increase method. I just won't go into the detail. I'll just go through gate point of view. I'll be saying whatever the examples and whatever the formula and what is the concept. So we'll be finishing it off very fast. Arithmetic increase method. So this is time. If we draw a graph between time and population, For the arithmetic growth, there is a constant growth rate. So there is a constant growth rate in the arithmetic mean method, arithmetic increase method. So here arithmetic increase method is estimated as Pn is equal to P0 plus n into x bar. So what is Pn? Population by end of nth decade. P0 is latest population known. N is number of decades. And x bar is average of population increase. So here Pn is the population that we need to find out in the future. For example, we know the Indian census. For every 10 years, the government of India will be taking the population census. So right now we know the previous data which that is available is 2011 census data. This 2021 census data that will be that is going to be available very soon. So right now if I for example if I know the population of 2021, so I am designing my distribution system for 30 years. So I need to know by the end of the design period. I need to know the population of the city. So by the end 30 years, for example 30 years, then I need to know the population by the end of 2051. So the Pn is the population in 2051 and P0 is the present latest population known. Latest population census is 2021, that we know. So P0 is the population in 2021 and n is the number of decades that we need to calculate. So if we know 2021 and we need to estimate in 2051, that is number of decades. Number of decades is 2021 to 51 is 3 decades. So n will be 3 and x bar is the average of the increase in the population. So this is the formula, and using this formula we'll be finding out the future population. You just note down this formula. When we solve this problem, you will be clear about the concept. So you just be familiar with the terms, whatever the terms are there, and be familiar with the formula so that we can find out what is the population. When we solve the problems, your doubts will be cleared. This is what is the arithmetic increase method. This is constant. The second one is the geometric increase method. So geometric increase method is another type of population forecasting method. This method will be using it in young and rapidly growing cities, because the growth in the geometric increase method will be exponential, while the growth in arithmetic increase method will be constant. So here, if there is an exponential growth, how will the curve will be? So here, if we draw time versus population graph, so time versus population graph, if I am drawing, this will be the geometric increase method. So this is mainly applied for the rapid growing cities. For example, Surat. Recently there was a news, Surat and Hyderabad and Bangalore and even Mumbai. These cities comes under rapidly growing and young cities, because the scope for the expansion of the city is more. Because in the future the population increase in these kind of cities will be more. So according to that, if you are designing if you are designing a water distribution system in Surat or in Bangalore, will be using geometric increase method because the rate of growth of the population from the previous data census is very high. So exponential growth. So this geometric increase method, the population can be forecasted by the formula Pn is equal to P naught into 1 plus R bar whole power n. So here we know what is Pn. Pn is the population in the future that we are going to estimate, and P naught is the present latest population that we know, and n is the number of decades that we are calculating, and here R bar, rate of increase of the population. So R bar is the term that we use in the geometric increase method, is nothing but the rate of the increase of the population. Here it is just the increase in the population, here the rate of increase. So when solving the problems, you will be cleared with this concept. So we have finished arithmetic and geometric. So the third method is incremental increase method. So the next we'll be seeing is the incremental increase method. Incremental increase method, this is nothing but the extension of arithmetic increase method. So here this is incremental increase method. So if the population trends, previous population trends, if it is growing at a constant rate, then we adopt arithmetic increase method. If the previous population trends is growing in an exponential way, then we adopt geometric increase method. If the population is ambiguous, like it's confusing, for a decade it's increasing and for the next decade it's decreasing, there is no constant population growth pattern, then we assume incremental increase method. Here the population may vary, so this method will be for this incremental increase method, the population will be forecasting based on this formula. Pn is equal to P naught plus nx bar plus n into n plus 1 by 2 y bar. So this is the formula for the incremental increase method. This is already formula for arithmetic increase method. So this is extension for incremental increase method. So this is the arithmetic increase method, but we add another term, that is y bar. What is y bar? Y bar is increment of increase. Increment of increase in population. So by this method, there are different types of cities where incremental increase method can be used, because there may be different kinds of situation in that particular decade where the population has been decreased, and also later on due to the development again the population is getting increased. So there we'll be using this formula. We'll also be solving the problems on all the types, so you just don't need to worry. So finally the fourth method, last method, is decreasing growth rate method. So decreasing growth rate method is the final method. So here the rate of population growth decreases in the future, then we apply, this is decreasing growth rate. Decreasing growth rate method, mainly it may be due to any reason the population keeps on decreasing, the rate of population keeps on decreasing. So there may be any reason, because due to non-development, due to less GDP, less number of funds, and whatever the reason, the rate of population gets decreased in the future. So here, for the decreasing growth rate method, how will be the curve? For the time versus population curve, if I draw, this is the decreasing growth rate. So here decreasing growth rate method, it is calculated, formula is calculated as Pn is equal to P naught 1 plus R naught minus D bar 1 plus R naught minus 2 D bar plus so on plus 1 plus R naught minus N D bar. So this is the formula to calculate population by decreasing growth rate method. This formula might be complicated, just seeing it might be complicated, but it is very simple. You just when we'll solve the problems, your doubts will be cleared. And here R naught is latest population growth, latest population growth rate, and D bar is decreasing growth rate. So here we already know what is P naught, what is Pn. Pn is the population in the future, and P naught is the latest population that is known, and N is the number of decades that we need to calculate. So these are the major 4 methods that we'll be using. This population forecasting methods will be estimating future population that is required in the water demand, calculating the water demand of the city. So these are the 4 methods. Next we'll be solving each problem in each method. Okay, so this is the example problem. We'll be taking this same example problem and we'll be solving in all types of methods. So this is like the simple example. Based on this example, you can solve any problem which is present in previous gate questions and previous IES, ESC questions and anything. So any problem you can be solving after just going through this example. So this is what is the example I'll be taking for all the methods. Here population is given and the respective year is given. So what we need to estimate in the population in 2030. So what is the population in 2030? Yes, we have known the population trends up to 2010. So 2010 is the latest population that we know from the year 1970. So first method that we'll be calculating is the arithmetic increase method. So what is the arithmetic increase method? We know what is the arithmetic increase method. Formula Pn is equal to P naught plus N into X bar. So what is P naught? P naught is the latest known population. P naught is equal to what is the latest known population, that is the year 2010, 47,000. Okay, and N is the number of decades that we need to calculate. N is equal to 2 decades because we need to calculate in 2030. The latest known data is in 2010. So number of decades from 2010 to 2030 is 2 decades. So N value will be 2. And X is increase in population. So how do you calculate the increase in population? So this is what we'll be drawing another column. Here we'll be calculating X bar. So X bar is nothing but what is the population increase. So here P2 minus P1, the population in the next decade minus the population in the present decade, that will be getting difference in the population, increase in the population. So 28,000 minus 25,000 here, X bar is 3,000 here, and for the next 2 decades that is 5,000, 6,000. For the next 2 decades is 8,000. For the next 2 decades is 5,000. So X bar is the X is the increase in population. So what is X bar? X bar is equal to average of increase in the population will be X bar. So we can calculate X bar is equal to 3,000 plus 6,000 plus 8,000 plus 5,000 by 4. We'll be getting, I'm directly writing the value, you can calculate and you can solve the problem. Here we'll be getting X bar is equal to 5,500. So substitute all the values in the equation. Pn is equal to, what is P naught? P naught is 47,000 latest known population plus N is 2 decades and X bar is 5,500. So here P in 2030 is equal to, just do the calculations. I'm writing down directly. So 11,000 plus 47,000 is 58,000. So here, according to this problem, we have estimated by the arithmetic increase method the population in 2030 will be going to be 58,000 by the arithmetic increase method. The latest known population is 47,000. So if your design life of the water distribution system is up to 2030, then you need to design for the population of 58,000 but not 47,000. So 58,000 is the future population that we have estimated. It may be true, it may not be true, but based on the previous trends we are trying to estimate. So for the same example, right now I'll be solving by the geometric increase method. So by the geometric increase method, the same, we need to estimate the population in 2030. So what is the population in 2030? I don't know. By the geometric increase method, I know what is the formula. Pn is equal to P naught plus 1 plus R bar whole power n. This is the formula from the geometric increase method, right? This is the formula in the geometric increase method. Then the next problem. So here, what is R bar? R bar is equal to R1 into R2 into R3 into so on Rn whole power 1 by n. So here, what is R bar? R bar is nothing but the increase in the population, percentage increase in the population. So how do you calculate the percentage increase in the population? R1 is equal to P2 minus P1 by P1 into 100. So here 28,000 minus 25,000 by 25,000. So this will be getting R bar. Nothing but will be getting R bar. R bar is 0.12%. So this is R1 is equal to 0.12%. R2 is equal to 0.17%, 0.19%. I'm calculating directly you just calculate using the calculator, because I have already solved the problem. So I'll be directly writing the values. You can just cross check it. R4 is equal to 0.104%. So these are the different R values. R1, R2, R3, R4 is the rate of increase in the population, percentage rate of increase in the population. So now my next step is R bar. R bar is equal to 0.12 into 0.17, 0.19 into 0.104 whole power 1 by 4. So there are 4 values. I'm multiplying all the values and having the power of inverse of number of values. So 1 by 4, I'll be getting R value as, so just calculate this R value. Okay, how much R value we are getting? Yes, so R value is 0.142. %. So we know all the values, substitute in the above equation. So Pn, that is population in 2030, is equal to latest known population P0 47,000 into 1 plus R bar is 0.142 whole power n. So we are calculating it for 2 decades. So population in 2030 will be, so directly calculate from this, will be getting 61,336. So the population by the geometric increase method by the end of 2030 is 61,336. So here you observe it. From the first method, arithmetic increase method, the population which we have forecasted is 58,000. But here it is 61,000 because the population by this geometric growth rate method is more, because there is an exponential increase. So the same problem again we'll be solving it for the incremental increase method. Okay. So incremental increase method is nothing but the extension of arithmetic method. We know what is the formula and we know what is the different terms, and we know when we need to calculate in the 2030. So the number of decades are 2. So we can do that. Here incremental increase method, what is the formula? Pn is equal to P0 plus n into x bar plus n into n plus 1 by 2 y bar. Right? So here what we know, x bar. What is x bar? Difference in the population. We have already calculated 3,000, 6,000, 8,000, 5,000. 3,000, 6,000, 8,000, 5,000. These are the x bar. So next term is y bar. Y bar is the increment of increase. Increment of increase is the difference in this population. So xi is equal to p I plus 1 minus pi. This is the formula. If I need to find x1, p2 minus p1, and yi is equal to yi minus y, sorry, xi minus xi plus 1. So if I need to calculate y1, I need to x1 minus x2. So that is the formula of x and y. So here what will be the y bar? Y1 is x1 minus x2. So x1 is 3,000 minus 6,000. So we need to write whatever the value which we get, even if it is negative or positive values, we can directly write here. So y bar is minus 3,000. Here 6,000 minus 2,000. So 8,000 minus 5,000 is minus 3,000. So these are x bar and y bar values. So we know what is x bar. x1 plus x2 plus x3 plus x4 by 4. We have already calculated, value is 5500. What is y bar? Y bar is y1 plus y2 plus y3 by 3. Right? Okay, what is the value? This is plus 3000, minus 3000, 2000. That is like minus 1000, right? Okay. 3000, 3000, 2000, 2000 by 3. Yeah. So this is y bar is 2000 by 3. So substitute all this formula. Population in 2030 is equal to latest known population plus n into x bar 2 into 5500 plus n into n plus 1 by 2 y bar. Y bar is 2000 by 3. So here if I calculate, I'll be getting, this is minus 2000, yes. So population in 2030 will be 56,000. So based on the incremental increase method, we just need to find the constant terms in each of the following method, and we need to calculate, we need to make a table, calculate, substitute the values, get the population in the future. That's it, simple method. So by this incremental increase method, we got the future population of 56,000. So there is a difference in each method. By the arithmetic, we got 58,000. By the geometric, we got 62,000, 61,000 change something. And by the incremental increase method, we got 56,000. So here it depends. It depends on different types of method. And the next and the final method. If we solve the final method, then that's it. What is the final method? That is decreasing growth rate method. We know the formula. What is decreasing growth rate method? Pn is equal to P naught into 1 plus R naught minus D bar 1 plus R naught minus 2D bar plus so on. Okay. What is R naught and what is D bar? We know all those things. This is R, this is D. We know what is R. R is the percentage increase in the population. So R is, we have already calculated before, 0.12%, 0.17%, 0.19%, 0.107%. So this is the rate of increase in the population. And then D bar. So D bar is nothing but the difference in R bar, R1 minus R2. D1 is, so difference in the rate of increase is D bar. So we get 0.05% minus 0.02%. So here we'll be getting plus 0.084. So what is D bar? D bar is average of D1 plus D2 plus D3 by 3. So we'll be getting D bar 0.0046. So D bar is the average in decrease in the growth rate of the population, we get as 0.0046. So substitute all those values in this formula. So P in 2030, P naught is 47,000. What is R naught? R naught is the latest known population growth. Latest known population growth. So what is the latest known population growth? That is this thing. R naught is equal to 0.107. Here 0.107 minus D bar 0.00046. So we need to calculate it for 2 decades. So into 1 plus 0.107 minus 2 into 0.0046. So n value is 2. So we need to stop up to 2. So the next term will be 0. So here you can just calculate this formula. Whatever this formula you will be getting by the population in 2030 is 56,776. So by the decreasing growth rate formula, the population in 2030 is 56,776. So these are the different types. I have taken single example, and based on the single example I have solved different types of population forecasting, and you can see there is a difference in each method, the value which we obtain. So based on the type of the city and whatever the circumstances there, though we'll be selecting appropriate method for that and will be solving so that you can get this data. So these are the major 4 methods and examples of each method. Okay, so we have calculated the population forecasting now. So what we'll be doing with this population forecasting? How we'll be estimating water demand? So I have calculated my population forecasting. Now Q is water demand. So Q is water demand. For the particular city, I have calculated the population. For example, in the 2030, the population in city X have calculated as 1 lakh. 1 lakh is the population of the city. So if there is a population of 1 lakh, how much water should I supply for the city? So that you can be calculating by water demand. So Q is equal to population into per capita water consumption. So population into per capita water. What is per capita water consumption? For each person, the amount of water that he is consuming in a day is called as per capita water consumption. Per capita water consumption given by IS codebook. IS 10500 10500 is the codebook that we need to follow for the environmental standards. So according to that IS codebook, the per capita water demand for the domestic use is 135 to 200 liter per capita per day. LPCD is liter per capita per day. So domestic. Industrial is 50 LPCD. And next, institutional. So institutional is 20 LPCD. Public use 10 LPCD. And next is theft, losses and theft, 55 LPCD. So these are the different uses and their respective water demands. So these are given by IS codebook. So for the domestic use, for a person in the home, for the domestic use, for bathing, cooking and drinking and whatever, all those things, he consumes daily 135 to 200 LPCD given by code book. So industrial area consumes 50 LPCD. 50 LPCD, how will be calculating? If suppose in an area there is an industry, so the population in that area is 1000. So how much water that should be supplied for the industry? So 1000 into 50 LPCD. So 50 into 1000. So 50,000 will be the extra amount that the industry will be using. So same institutional is water supply for the schools and buildings and hospitals and all those things, 20 LPCD. And public use is 10 LPCD. Public use is for the cleaning of the roads and whatever, uh, for for the trees and all those things will come under public use. And losses and theft, there may be leakages and there may be theft. In India, it's quite common that you can just take an illegal connection, so that you'll be getting an extra water. So that all comes under losses and theft, that is 55 LPCD. So total 272. So this is per capita water demand. Per capita water demand 270 to 335. 270 to 335 LPCD. This is given. So right now I know the population, I know the per capita consumption. So I can find out Q average is equal to population into per capita demand. So here we'll be getting Q average. Now we have to find Q max daily. These are given by the different factors. Q max daily is 1.8 into Q average. So Q max hourly is equal to 2.7 into Q average. So these are the different factors that you need to remember. For the daily maximum water demand daily, we need to multiply by the factor of 1.8 with the Q average. Q average, what is the Q average? We have found out population into per capita demand. And Q max hourly, what is factor that should be multiplied with 2.7 into Q average. So there are different terms: Q max hourly, Q max daily, and what is Q max Q average, and there are different terms. So what is the exact water demand? Water demand. So there is one more term, coincidental draft. Coincidental draft is Q max daily plus fire demand. So coincidental draft is nothing but Q max daily plus the fire demand. So what is water demand? From this all terms, Q max hourly or coincidental draft. So whichever is highest. So whichever is highest in both of these terms, we'll be taking this as water demand, and we'll be constructing water distribution system for that water demand. I have calculated all these things. For example, for the city, I have got the water demand as 10 MLD, 10 million liter cube per day. So for that 10 million liter cube per day, I need to construct a water distribution system. So this is the first topic that we have finished it today, that is population forecasting. How we'll be estimating the future population, and by using that future population, how you'll be finding the water demand. So we have solved some examples also, and this is also this is water demand. So In the next class, we'll be seeing our upcoming topics, that is quality of the water and the primary sedimentation tank, and all those things we'll be seeing in the next chapter. Thank you.